So AI assistants are getting crazy powerful, right? But that power, it brings up a huge question. How do we make sure these tools are not just useful, but also completely safe for everyone? So let's dive into how researchers are actually tackling this puzzle. And this, right here, is the central puzzle. Think about it. An AI that's always trying to be helpful could end up helping with some pretty dangerous stuff. But an AI that's too focused on being harmless might just refuse to answer simple, totally legitimate questions. It's this super delicate balancing act. So how do you solve this? Well, researchers at Anthropic came up with a really clever approach. Instead of trying to hard code a bunch of rigid do this, don't do that rules, they did something different. They decided to teach the AI using direct feedback from real people, kind of like how you'd teach a student, showing them which answers are good and which ones not so much. Okay, so the fancy name for this is reinforcement learning from human feedback, or RLFF for short. You can think of it as a three-step dance. Step 1, you collect a ton of feedback from real people. Step 2, you use all that data to train what's called a preference model. You can just think of this as an AI judge that learns what humans actually prefer. And finally, step 3, you use that AI judge to fine-tune the main AI, constantly rewarding it and nudging it toward better and better responses. But where do you get all that human feedback from? Well, this is where it gets really interesting. They hired a bunch of people and split them into 2 totally different teams, each with a very specific job. So on one side, you had the helpfulness team. Their whole mission was to ask the AI for genuinely useful things. Write an essay, explain a tricky concept, maybe fix some code. And then on the other side, you have the red team. And their job? The exact opposite. They were tasked with trying to trick the AI, to provoke it into saying something harmful or inappropriate. And that's the key, right? These 2 teams had completely opposite goals. The helpfulness team was always trying to steer the conversation in a good direction, choosing the most beneficial response. Meanwhile, the red team was told to pick the response that would push the conversation in a more harmful direction. They were actively trying to lead the AI astray to see what would happen. And this is a great look at the actual tool they used. So at each point in a conversation, the AI would come up with 2 different ways to respond. The human teacher then just clicks. They choose which one is better. Or if you're on the red team, you choose which one is worse. And every single one of those clicks was like a tiny little lesson for the AI. Multiply that by thousands and thousands of times, and the AI starts to really learn what we humans prefer. Okay, so now for the really cool part. What actually happens when you train an AI using only one of these datasets? Let's check it out. So if you take an AI and only train it with the helpfulness team's data, you get exactly what you'd expect. It gets really, really good at being helpful. But there's a huge catch. It has absolutely no concept of harm. It just wants to please you. So it becomes this kind of people pleaser that can easily be tricked into giving out dangerous information, all because it's just been trained to be agreeable. Now let's look at the flip side. If you train it only with the red team's data, basically teaching it only what not to do, it becomes incredibly safe. The problem is, it's so paranoid about messing up that it just refuses to answer almost anything, even perfectly innocent questions. So yeah, it's harmless, but it's also totally useless. But this is where the magic happens. When the researchers trained the AI on a mix of both the helpfulness data and the red team data, it finally learned that balance. It figured out how to be a super helpful assistant that could also politely but firmly say no to dangerous or inappropriate requests. Basically, it learned how to be useful without being a liability. Okay, so the logical assumption here would be that adding all these safety guardrails would slow the AI down, right? That there'd be some kind of safety tax on its performance. But what they found was something nobody really expected, especially when it came to the biggest, most powerful models. For the smaller AI models, yeah, there was a tiny performance hit. Researchers call this an alignment tax. But for the really large models, something incredible happened. The safety training didn't cost them anything. It actually gave them an alignment bonus. It turns out, the very process of learning to be helpful and harmless actually made them smarter and more capable across the board. Wild, right? And we're not just talking about general trivia here. They put this to the test on really specific skills. For instance, they had a model that was an expert at summarizing long articles. When they added all this helpfulness and harmlessness training, its ability to summarize didn't drop at all. It was just as good as before. And it gets even better. The same thing happened with writing code.
This alignment training actually made the model better at following complex instructions and writing clean Python code. The takeaway is huge. You can make an AI safer, and you don't have to sacrifice its special skills to do it. Which, of course, leads to the ultimate question. The AI is safer, it's smarter, but how good is it really? Like, could it actually go head-to-head with a professional human writer? So, to find out, they set up a direct competition. They hired professional writers and basically told them, your job is to act like the perfect AI assistant. Then, they showed these conversations to a new group of people, side by side, one response from the human pro, one from the AI. And the key was, the judges had no idea who wrote which. They even used an ELO rating system, just like they use in chess, to score the head-to-head matchups and rank the winner. And the results? It was absolutely stunning. People preferred the AI's response over the one written by a professional human writer 57% of the time. So the AI wasn't just holding its own, it was actually winning the majority of the time. Okay, so the AI is trained really, really well. But what happens when it gets out into the wild and someone throws a totally bizarre, completely unexpected curveball at it? For that, there is one last line of defense. It's a system called out-of-distribution detection, or ODD. Honestly, the best way to think about it is like a bouncer at a fancy club. Its only job is to stand at the virtual door and check every request that comes in. It learns what normal, everyday requests look like. And if something comes along that seems just off or weird or malicious, it doesn't even get in the door. So let's say a user sends in a really strange or clearly harmful prompt. The OD system immediately flags it as an outlier. And here's the best part. The main AI model never even sees it. The request gets rejected outright before it has any chance to cause a problem. It's a really simple but incredibly effective final safety net. All right, so we've covered a lot of ground. What are the big takeaways here? First, teaching AI using direct feedback from real people is a super powerful way to instill complex values like helpfulness and harmlessness. Second, and this is a big one, for the largest AI models, safety and capability aren't enemies. Making them safer can actually make them smarter. That's the alignment bonus. Third, AI-generated writing is now officially at a level where it can compete with and even beat professional human writers. And finally, when these things are deployed for real, they use multiple layers of safety, like that bouncer at the door, to keep everything secure. And all this research leaves us with a really powerful thought for the future. Maybe safety isn't just some extra feature you bolt onto an AI at the end. For the truly powerful models that are coming, maybe being helpful and harmless will become a core part of their very definition, a fundamental piece of what it means to be an AI.